Okay, we're going to get started here today. Today we're going to be covering just a couple, this will be a real quick one. We're just going to cover a couple different factoring techniques that you'll need for 8.3. So the first one that we're going to do is we're going to cover difference of squares. So the two blue ones below are difference of squares. And reminder on how you tell. So what we do is we look at the first term and we say, is this a perfect square? Yes, it is. Is this a perfect square? Again, yes, it is. Are they put together with a difference sign? Yes, they are. Okay, if all three of those things are true, then you have a difference of squares. And what you do is you take the first term and you take its square root, which is 5x, plus the square root of the second term. Then all you do is multiply this by its conjugate, which is the same thing but put together with a minus sign. Okay, so that's just again a reminder of difference of squares. What you should do right now, if you're watching this video, is you should pause it and go through and try the second one. So let's go and do that. So again, I'm going to go and check. Is this a perfect square? Yes, it is. Is this a perfect square? Yes, it is. Is this a difference sign, a minus sign? Yes, it is. Okay, then we have a difference of squares. So again, we get the square of the first plus the square of the second multiplied by its conjugate. Square of the first minus the square of the second. Okay? So that is difference of squares. Now let's look at perfect squares. Okay, so with perfect squares, what we're going to do is we're going to again look at a couple things. So the first thing I'm going to do is I'm going to look at the first term and I'm going to ask myself, is it a perfect square? Just like I did in the difference of squares. And the answer is yes. Then I'm going to look at the last term. I'm going to ask myself again, is this a perfect square? The answer is yes. So the last part, and this is the part that always gets students, is you take the square root of the first. So I'm going to take the square root of 4x squared, which is 2x. I'm going to multiply that by the square root of the second. So the square root of 9 is 3. Then I'm going to take this whole thing and multiply it by 2. Always multiply by 2. If this product equals this middle term, you have a perfect square. So let's see. 2x times 3 is 6x. 6x times 2 is 12x. Yep, it works. Once you know that you have a perfect square, then all you do is you take the square of the first, sine of the second, square of the last, quantity squared. So let's look at another example. Okay, so again, let's go through our checklist here. So let's see. Is the first term a perfect square? Yes, it is. Is the last term a perfect square? Yes, it is. Okay, negative 40x. So if we take the square root of the first, which is 4x, times the square root of the second, which is 5, and multiply it by 2, do we get the middle term? Let's see. 4x times 5 is 20. 20x times 2 is 40x. Yes, we do. Again, notice I'm not really worrying about that middle sign right now. I take care of the middle sign once I go to put this together. So again, once I go to put my answer together. So the square of the first term is 4x. Sine of the middle is minus. Square of the last is 5. Okay. There's one more. There is one more idea that we want to do here. And this one's, we've talked about it already, but this is just the GCF, where we pull out the greatest common factor. So, in order to do the greatest common factor, let's say I had 4x squared plus 16x. In this case, what I do is I'd say, is there a number that goes into both terms? And if there is, what is the biggest number that goes into both terms? So I think you'd agree that 4 is the biggest number that goes into both terms. Then I say, what is the biggest variable that goes into both terms? Well, the highest, what we call the highest degree variable is x. X is in both terms. Both these terms are divisible by x. So this is our greatest common factor. And then what we do for the parentheses is I'm going to take each of these terms and divide them by 4x. So 4x squared divided by x squared, one more time. 4x squared divided by 4x is just x. 16x divided by 4x is just 4. And I can check myself. Let's see. 4x times x is 4x squared. 4x times 4 is 16x. And that's the pulling out the greatest common factor. So let's do one more. So in this case, let's see what we got. Actually, yeah, let's see what we got. So the first thing we're going to do is we're going to ask ourselves, in all the terms, is there a number that goes through into all of them? And I think you'd agree, 5 goes in all of them. Is there a variable? Yes. X divides into both of them, so I'm going to pull out an x. So what does that leave me with? Well, 25x squared divided by 5x is 5x. 5x divided by 5x is 1. And again, I can check it. 5x times 5x is 25x squared. 5x times 1 is 5x. Okay, so that is today's lesson. Again, it was a nice short one. I do want to remind you, if you have any questions regarding the packet, please make sure you ask them in Discord, in the IM2 questions and information channel. Okay. Otherwise, that is today's live stream, and I hope that it helps you out with the rest of the packet. And I will talk to you next week.